This is video number 2 for 6.2. This time we're going to be graphing natural base functions. Alright, so before we get started on that, let's go over a core concept. Natural base functions. They look like this. We have growth, we have decay. Okay? Since there's growth and decay functions, they both go through the point 0, 1. Okay, so a function, the form y equals a e to the rx power is called the natural base exponential function. A has to be greater than 0, so it's positive, and r also has to be positive. The function, if those are both true, then it's a growth equation. If a is positive but r is negative, which means your power will be negative, then it's a decay function. So the graphs of basic functions are y equals e to the x. Notice it's positive, so that'd be growth. Or y equals negative e, or I'm sorry, x, e to the negative x. Notice the power is negative, so that would be decay. Alright? So, and to find the second point, if you plug 1 in for x, the y value is what you get. So we rounded this because e to the first power is a number that goes on forever. And in here, I would say e to the negative 1 power, which is 1 over e, okay? And that, again, is a number that goes on forever, so we have to round it. All right. So now we're going to go on. We're actually going to graph some of these. So we're going to start with number 4. All right, so our function here is y equals 3 e to the x power. So let's write down the parts that we have. So our normal equation is y equals a times e to the rx power. So we have a couple of things here. We have a, and that's 3. R, in this case, since there's nothing multiplying the x, it's 1. Since this is positive and this is positive, we know it's growth. Okay, our power is positive, it's going to be growth, okay? Alright, now because we have an a out here, it's not just going to go through that point 0, 1. You should think of that point as it's going to go through the point 0, whatever a is, okay? And then it's going to go through 1, and it's going to go through e to the r power. Okay? Alright, so let's plug these in. Well, actually be a e to the r power. I'm sorry, that would be an a there. Whoop. Alright, so I know it's going to go through, if a is 3, it's going to go through 0, 3. Alright? Now the easiest thing for you to do is you could actually just do a little quick table. 0, we know that's 3, and 1. And plug 1 into your equation. So because I don't calculate that, that number that goes on forever and ever in my head, I'm going to just type in 3, and then I have e, and it goes to the x power, and I'm plugging in 1 for x. And that gives me we'll just say 8.2. I'm rounding it so I can draw it. So 1, and then it goes all the way up to 8.2, which is like way off my graph. Okay, so this is exponential growth or decay, right? This is obviously growth, because it was positive. We said it was growth. That's important. Now, I need to know where my asymptote is. So this is just like the other exponential growth functions we did. There's no movement up or down or left or right. So my asymptote stayed at that x-axis, and I always like to draw my asymptote as a dashed light line, just so I know I do not cross that line. Remember, it means the graph approaches it infinitely. So I kind of start low, and I'm going to go through these 2 points, and it'll look like that. Okay, let's try number 5. Okay, and this time a is 1, which is positive. S, sorry. All right, and we have r is a negative 0.5, which is negative. So whenever a is positive, r is negative, we have exponential decay. All right, again, let's just do our little chart here. Okay, remember, it's 0, comma a is 1, so I know I have that point. And I'm going to plug 1 in for x and see what I get. So again, I take this equation, I type e, and the power is a negative 0.5 times 1, because I'm plugging in 1 for x. And that gives me we'll just say it's 0.6. So at 1, I go 0.6, so it's decay, because you can see it's from right to left, it's starting to go down. There was no shifting up, down, or left or right, so I'm just going to put my asymptote at the x-axis so I know not to cross that boundary. So I start up high, and I'm going to go through those 2 points, and I'm going to approach that asymptote. All right, so now you're ready to go to the practice and do problems 16, 18, 22, 20, and 22.